Right. So this question says that normal at points PQR of the parabola y squared equal to 4ax are concurrent in a point on the line y equal to 2a. So I have graphed the parabola y squared equal to 4ax over here. And as for the points, I will be using 81 squared to 81, which will be my P. And then similarly, Q and R are parameterized like this. And they are saying that normals at these points, they are concurrent on a line y equal to 2a. So we know that the normal at any point parameterized by the t parameterization, that thing is just given by y equal to negative tx plus 2at plus at cubed. Now, if this normal is passing through some kind of point which has y coordinate as 2a, you can just replace this by 2a. And now this is a cubic in t. So as you can see over here, we can write this as at cubed plus t into 2a minus x minus 2a equal to 0. So from this you can say that the sum of its roots, so the roots in this case are just the points, are just the t values t1, t2 and t3, because they said that the normals at the 3 points PQR, those are concurrent, right? And they are concurrent on a point which is on y equal to 2a. So y equal to 2a, I even have that. So this line, it's going to be on that, and these are our 3 normals. So as you can see, these will be concurrent. So yeah, this is actually very far away, but we can change our t values such that, all right, now this is slightly more, right? So now we can see that these are, I'll have to zoom out. Okay, now you can see this, I think. So as you can see, this is, right, over here 2a is 6, and x value we don't really care about that. It's something we don't care much about it. And these 3 normals in red, so all of these are red, they are concurrent on one point, and that point is on this line y equal to 2a. So I'll just remove all of these for now. So because t1, t2, t3 are the roots of this equation, you can use the fact that t1 plus t2 plus t3 is equal to 0, because there's no t square term over here. And similarly t1, t2, t3, that will be negative of negative 2a upon a, which is just 2. Now, next thing the question says is, these are concurrent in a point on line y equal to a, we know that. And then the chords PQ, QR and RP of this parabola touch a fixed parabola. So what will the chord PQ be? So PQ, in fact, let me just tell you that the chord between any two parameterized points with the parameterization values t1, t2, right? That chord, that will be given as y into t1 plus t2 upon 2 equal to x plus a t1, t2. So you can clearly see that when t1, t2 are the same thing, so it should be t1 over here. So you can see that when t1, t2 are the same thing, this just becomes y equal to x plus a t square, which we all are familiar with. It just becomes a tangent, right? But this chord, we can write this thing, because we know that t1 plus t2 plus t3 is equal to 0. We can write this quantity as negative t3. So it's just negative t3 upon 2 times y equal to x plus a t1, t2. But we also know that t1, t2, t3. So the product of those 3, that is 2. And that means t1, t2 is basically just 2 upon t3. So this thing will just be 2a upon t3. From that, x is equal to negative t3 upon 2 times y negative 2a upon t3 times x. So I have also, right, graphed those lines. So this will be what those lines will look like. So you can see these are all the chords. Cool. And now you might be thinking, okay, over here we have t1, t2, t3 equal to 2 and t1 plus t2 plus t3 equal to 0. Where did I use this fact in my graphing? Well, I did use this because look at these two equations. So if you solve this using the quadratic formula, you will get t2 in terms of t1. Well, there's supposed to be plus minus over here, but then I'm only going for the positive version. So as you can see, t1 square minus 8 upon t1, that should be positive, and that means that whenever t1 is between 0 and 2, this thing just goes like, I don't know what to do with it. It's some imaginary number. We can't do it. So let me show you. When, yeah, so you see it just disappeared, right? It's not three normals anymore. It's just, sorry, it's not three chords anymore. It's just two chords. So it doesn't know what to do with it, right? The thing is, like over here, t1 square minus 8 upon t1, that actually becomes 0. So this particular value 2, this makes t2 equal to 0, and then when it actually goes below it, now there's only one line, and then it will keep on going till 0, and at 0 it once again doesn't know what to do, and then this happens once again. You get three lines like that. So this is all fun and good. The thing is, the question asks that these three chords, these are tangents to a fixed parabola. So think about it. A parabola is basically just capital Y squared equal to 4a, I should say capital A, and then capital X, where capital Y and capital X are distances from two lines, sine distances from two lines which are perpendicular to each other. And we know that the tangent to such a parabola, that will be capital Y equal to capital mx, well, let's just say small mx, because we haven't used small m yet. So small m times capital X plus a upon m. Cool. But now look at this thing. This is supposedly a tangent to a parabola. Look at it. Capital Y, if we set capital Y to be equal to x and capital X to be equal to y and small m to be equal to negative t3 upon 2, you can clearly see that this shouldn't be x over here. Sorry, this was just a constant, right? There's nothing else involved over here, so it's just negative 2a upon t3, right? And yeah, or in fact we could write this in a better format so that you would understand what I'm saying. So this, we can write this as a upon negative t3 upon 2. And now you can see that yes, capital A upon m, it just becomes this thing, it's the constant term, and over here capital A is the same thing as small a. So let me just write it down. Capital A is small a, small m is negative t3 upon 2. Well, that's not actually very important, because we just want capital Y, capital X, and small and capital A, right? Then we will know what parabola we are talking about. So capital Y, that is small x, and capital X, that is small y. So our parabola, this thing, that will just be the parabola x squared equal to 4ay. So I have graphed that over here as well. X squared equal to 4ay is this parabola, and you can see that yes, these purple lines, they are tangent to this parabola. So it doesn't matter what value of e1 I set. I mean, it does matter because can't go below 2 and more than 0. But yeah, for other values, you see it's still tangent. So just zoom out a bit. See, it's tangent over here, tangent over there, and tangent over here. Now it might not look very clear from such a large perspective, but yes, these two are tangents, and so it works out. So the answer of this question is that the parabola that we're looking for is just x squared equal to 4ay. Now let's just remove all these lines and points. In fact, if we don't remove points, it's still okay. So as you can see, these two are the parabola that we are talking about. So this is the parabola that they want us to find, the fixed parabola, and this is the parabola that they gave us. So now they ask, vertex of the parabola that we want to find, this white parabola, that is, so yeah, it's 0, 0, as you can see. Latest rectum length of this parabola is the same as that of the given parabola. Yes, it is. So 4 small a, right, x squared equal to 4a y, it's the same length, right? The two parabolas are reflection of each other in x equal to y. Very correct. So let's just graph x equal to y. In fact, you don't even need to graph. You can clearly see that over here y is changed with x and x with y. So it is in fact just reflections, but still, let's just say x equal to y. If we graph this, you can see that yes, these are reflections. Right, cool. And then they say that the two parabolas are having the same focus. Well, no, this has the focus y equal to a and x equal to 0, and this has focus x equal to a and y equal to 0. So a comma 0 somewhere over here, and this would have 0 comma a somewhere over here. So no, these don't have the same focus. And yeah, that's it. This question is solved. So that's it. I'll see you guys in the next video.